Hi everyone, thanks for joining in to listen to Properties of Exponents. So today we are going to talk about what to do if we see negative exponents. So here are two examples right here where we see negative exponents. We have 5 to the negative first and we have 1 over 7 to the negative squared. Okay, so the first thing I notice about these two are the negative exponents, and they, quite frankly, they just look weird. So we're going to go ahead and eliminate the negatives, and this is how you do it. Anytime you have a negative exponent, I know that this whole thing goes together, and we're pretty much bringing it to the denominator right here. We're bringing it opposite direction. So essentially, it's 1 over 5 to the first. We brought this down underneath into the denominator to make this positive, and we just put it underneath the 1, just a normal 1. When we are doing fractions, we're putting it underneath because this would have been a 5 over 1 already, so we're just bringing it underneath. So let's look at this example. If we have a 7 to the negative second power, we know we don't want the negative, so we're bringing this one up. So if we were to bring this one up and essentially flip it, get that reciprocal, it would be 7 squared over 1. And see, we brought it to the top because it was at the bottom, so we brought it to the top and it made it a positive. So 7 squared is essentially 7 times 7, and 7 times 7 is 49. So that would be your final answer. So let's look at some more examples. Here we have b to the negative fourth power. We know that this goes together, and we know that there's a negative 4 as the exponent. So in my mind, I'm like, okay, that's going in the denominator to make it positive. So we're going to say b to the fourth goes at the bottom, and 1 is going to go at the top. We're just making it a fraction. Now let's look at this one. We know that we have 6n to the negative third. We know from previous lessons that these two go together. Okay, so we know that this piece needs to be in the denominator. Now we don't have to do anything with the 6. The 6 is just fine, so we can stay in the numerator. And then we're only bringing this piece down, n to the third, and it makes it positive. So all we're doing is either taking it from the top to the bottom or from the bottom to the top, just to change it from a negative to a positive. Now let's look at another example. So we have x to the negative fourth times x to the third. All right, we both see that they both have the x in common, and we know that they are multiplying. And when you are multiplying, what are you supposed to be doing with exponents? And we learned that we add those. So we know that we're going to multiply our imaginary coefficients like normal. So 1 times 1 is 1x, and we're going to say negative fourth plus the 3. And that is x to the negative fourth plus 3 is negative 1. Now, do I like this negative? No, I don't. So I need to take this whole piece and move it to the denominator. So that's actually going to be 1 over x to the first. You don't have to keep that first here. I'm just doing it because of the problem, so you understand what I'm taking in terms of the exponents. So like 1 over x would have been fine as well, but that's why I'm leaving that there. Let's go ahead and look at one more problem. So we have 8n to the third over 8n to the sixth. Okay, so we're going to go ahead and divide our coefficients like normal. 8 divided by 8 is 1. Okay, and then we know that we have n to the third divided by n to the sixth. And when we divide, what are we supposed to be doing with our exponents? We subtract. So we're going to say n3, this fraction mark means minus 6. And so we have 1n, 3 minus 6 is negative 3. Do I like this negative? No, I don't. So I know I'm going to have to move this to the denominator. So our final answer would end up being 1 over n to the third. Let me fix that 3 right here so it's clear. N to the third. Okay, and there is your answer.